Well, hello again out there in remote learning land. Today's hot topic, we're talking about gradients or slopes, how steep the land is, and actually calculating how steep the slope is from a flat map, which is kind of interesting. Today's do now questions, 46 to 48. I hope you worked hard on those. Let's get rolling into it. So when we talk about how steep the land is, you're always looking at it from a side view in real life for the most part, and you can see how steep it is. But on a map, you're looking at a top view, and it's a little bit trickier to see it right away. So we have this thing called a gradient formula that helps us figure out how steep the land is without actually even being there. All right, and of course, skiers know this better than anybody, right? Skiers love steep slopes, a steep gradient. And I want to show you two different examples of skiers here on two different slopes. So clearly this lady is more of a beginner, right? It's not a steep slope at all. Very flat. We call that a gentle gradient. She's having a good time, but certainly not going that fast because it's not that steep of a slope. And then you go over to the right side here, the Olympic skier.
Well, here is Miss Lake Louise, Lindsey Vaughn. She's been on the podium here 7 times in the last 4 seasons. 4 of those are wins in this downhill.
And just a gorgeous turn coming in the coach's corner. You can see her 5/10 ahead, a half second already. She's won this course 4 times in all sorts of different ways. Last year she won it on the bottom, coming from behind, and today she's already got the lead at the top. Here she is.
Look at how steep that is right there.
Her skis just leaving the ground just a little bit. Let's see how much speed she can carry on the flats.
Oh, she still has a pretty healthy lead here by 4/10 of a second.
Can she make it 5?
Lindsey to the line and into first place by 6/10 of a second.
Wow.
Pretty amazing stuff what a steep slope will do, right? You fly down there. So make sure you read this through. How do we define gradient? Normally in class, I have a little tank full of sand, and we run a little toy truck down there. And we change the gradient, and you can see it. But I think you get the gist at this point. The formula for gradient is right there. The definition of gradient. The formula is in your reference tables on the first page. Okay, and there it is. Hopefully that looks familiar to you. If you ever forget it, again, first page of the reference tables. So let's see if we can plug in some numbers here. Lindsey's race begins at an elevation of 700 feet and ends at 100 feet. So that's her change in elevation. Okay. 700 down to 100. That's going to go on the top part of the formula. Change in field value. So you're going to go 700 minus 100. And the distance, how far you actually skied, in this case it says 8 miles, so that goes on the bottom. And from here you simplify and solve. Right? 600 divided by 8 miles, and you end up with a slope of 75 feet per mile. Okay? Now, compare that with Tiffany over here. Tiffany started 400 feet. She ends at 200 feet. So much less change in elevation. And the distance was much greater. So she's not going down as far, and it's taking her a longer distance to do it. It looks like that on the picture there. When you set it up mathematically, well, 400 minus 200 divided by the 14 miles, you simplify and solve with your calculators, and you get a much smaller number, okay? 14 feet per mile as opposed to 75 feet per mile. This is called a more gentle gradient, and of course this is called a more steep gradient, okay? All right, that top view we're talking about looks like this. You're familiar with this at this point. Before doing any math, you should be able to say, oh, I see where it's going to be steeper, right? Where those lines are closer together. And you're right, now you just got to calculate how steep it is. Well, we got an interval of 20. It wants to know the gradient between points x and y. Well, y is 140, x is 100, so you're going to subtract those two. But Then you got to get a piece of paper and literally get the distance from here to here and go up to your scale. All right, literally mark that with a piece of paper. So I'm here, X, Y, on my paper. I slide it up to the scale, and I get about 1.5 miles. What does that look like? Well, it's the same formula. But now we're doing 140 minus 100. And now we divide by the distance, and that was that piece of paper you're going to slide up there. About 1.5 miles. Please use paper, not a ruler, because a ruler has numbers on it, and a lot of students confuse those numbers with these numbers. So please just use a blank piece of paper. Okay? Simplify and solve, and you'll have your answer. Okay? And there it is, 26.7 feet per mile. Make sure you remember your units, folks. The interval for elevation is feet in this case. For distance, it's miles. Sometimes the unit for this will be in meters and the distance in kilometers. All right, so make sure you're aware of that. Here we go. Let's do another one. Calculate the gradient between points A and B. Now, there's a curve in the river, so you're not going to be 100% accurate. Maybe you want to take this section and then this section, right, instead of going straight from A to B, to try to be as accurate as possible. The change in field value, well, that's going to be 300 minus 150. All right, that's going to be on top. And as far as the distance, again, take your piece of paper, go here and then here. So this plus this. You're going to have to go, obviously, beyond the scale. You have to slide your paper back over, okay? But you end up getting something about 4.7 miles. All right, divide that up. And you get right to here, 31.9 meters per mile. All right, I'll show you real quick what this looks like with the paper I'm talking about. All right, so you literally take a piece of paper, and from here, B to here is about that part of the river. So it's about this, right? Which is, I go up to here and I make a mark. So I'm at 2, slide it over, and about 2, let's say 2.5. So I would have 2.5 plus from here to here about. And that's another 2. So I would do 2.5 plus 2. I'm getting about 4.5. You're going to be more accurate than me. If you do it perfectly accurate, you get about a 4.7. But that's the paper method, and it works very well. Okay? All right, so what you folks have to do, I have a map here with a bunch of different profile lines. Gradient lines. You have to calculate the gradients from A to B, C to D, E to F, and G to H, using that same technique we just did. And then, of course, there's some summary questions after this. So spend a couple minutes, work hard on it. Obviously, we'll meet back in the meet and go through them, but take your time on it and try to get them right. Okay? All right, I'll meet you back in a meet.